All right, this is actually like our first new example in 5.4. And so in these problems, we are trying to solve these equations. It says solve each of the following polynomials algebraically. Briefly describe the methods of factoring you used based on the characteristics of the equation, and then create a sketch using your calculator. So we are going to do this. We're going to solve this equation by factoring. If you recall back in section 5.3, we did graph these things. We graphed these and talked about what the behavior of these graphs looked like. We used our graphing calculators, and now we're going to try to tie that all in. But we're going to take this and we're going to try to factor this first, right? So thinking back to everything we know, we want to factor out a common factor first. So we look at these three terms, and everything can be divided by at least a 2, right? So we can take a 2 out and also an x. So I'm going to go ahead and take out a 2x from this and rewrite this problem as 3x squared minus, this would be 10x minus 8. And then we want to try to take this trinomial now and see if we can break that up, right? We're going to take that and see if we can break that up into 2 parentheses. Maybe we can't, but we definitely want to try and see if we can do that. So the question is, can I factor that further? I'm going to double check that with the snowflake method and give that a go. So I'm going to have 3, negative 24, and negative 10. What multiplies up to negative 24 adds up to negative 10. So this is going to give me a negative 12 and 2, right? So negative 12 times 2 is negative 24, and if I add those, I get negative 10. So now I can indeed factor this. I do want to reduce any columns I have, so this column will reduce down to 1 and negative 4. So this will be an x minus 4. And then this column will be 3x plus 2. 3x plus 2. So we can factor it, and that's as far as we can factor it. Okay, I'm going to put this off to the side. Now what we're going to do is use the zero product property. We have this times this times this equals 0. So we use that same zero product property that says, well, one of these has to then be 0. So we can set them all equal to 0. We first have 2x, and we can set that equal to 0. We have the x minus 4. We can set that equal to 0 because that's a possibility. And then we have the 3x plus 2. We can set that equal to 0. So we can solve each of these 3 equations, and we can get 3 answers. So my first answer is x equals 0. Second answer is x equals 4. My third answer is going to be x. I'm going to subtract the 2 and then divide by the 3, so negative 2/3. So solving this equation, I get 3 answers, 0, 4, and negative 2. Now, so that's solving it. We got our 3 answers, and then it says to create a sketch using the calculator. Now there's a couple differences here from what we did before. You can see when we used our calculator in that last section, 5.3, we found the zeros on our calculator by using the actual graphing calculator and hitting 0. Now we algebraically figured out what the zeros are. These are the solutions here. Or we can think of them as the zeros of the problem. So when I go to my graph, I know that there are 3 zeros on my graph. One of them is at 0 right here. The other one is going to be at, let's see, 1, 2, 3, 4, and one of them's at negative 2/3, so maybe like right here. I already know that those zeros exist. And if you think about this x cubed, okay, and you think about what type of graph does an x cubed type of graph look like? Well, remember, an x cubed graph is going to go up and to the right, and it's going to go down and to the left. And we also had these little phrases, the ways to describe these end behaviors. But for now, I'm just going to show you, right, it's going up and to the right, down and to the left. So even without using my calculator at this point, I know that, this graph is going to be going like this, up and to the right, and then here's my other 0, it's going to be down and to the left. And I can pretty much fill in the gaps here without using my calculator. Okay, so I'm just going to try that. Say, well, I think it's just going to kind of go up, hit this next 0, and then it has no other place to go but down somewhere, and then come back up. So this middle part, I'm kind of guessing what those actual numbers are. It could look a lot different, but the general shape should be like that. And so if we look at our graphing calculator, so there's my graphing calculator, and I'm putting the function into my y equals. And then I can go ahead and just graph it, and I can see what I have here. And you can see that this is basically what I have on my screen here. I can probably pull them up side by side. Now you can see that the actual graph kind of goes up. It peaks here around 2 or 3, then it goes way down. I could figure out where that vertex is. It's way down there. But you can see that I at least have the general shape on my sketch. It goes up and then comes back down and then goes up and to the right. So what I would suggest doing is when you have this and when you solve it, put down your zeros on your graph. Try to think about the end behavior that we talked about before and just see if you can get the end behavior and see if you can kind of fill in the graph without actually graphing it on your calculator. But then after you've taken a good stab at it, then go ahead and graph it on the calculator and see how well you did and make any adjustments that you need to make. So back on my screen, I know that this was just my guess right here. I know the actual graph is like coming way down here to some point. But that's not the point of this exercise. The point of this is just to get a general shape, creating a sketch of my graph, and note here that my zeros that I have on my graph are going to be reflected in the solutions that I found in my equation. So that's really what we're doing in this example. Let's look at another one. So B, same exact thing, right? I'm going to solve this and sketch it, all right? So this goes back to my factoring skills. What can I pull out of this? I can pull out an x. They both have an x here. So this would become 4x squared minus 9. Now, this right here is the difference of two squares. So this is going to become x, and I can actually break that up into 2 more parentheses. And that's going to become 2x minus 3 and 2x plus 3. So we can break that down further. Now we've factored it completely, and now we're going to solve it using that zero product property. Okay, so each one of these 3 things we're going to set equal to 0, and that means that, of course, this lone x equals 0, that's going to be one possible answer. The other possible answer, if I set that equal to 0, is going to be x equals, I could add the 3 and divide by 2. So there's another possibility. And then if I set this one equal to 0, I would get negative 3 over 2. These are all my solutions of this graph, or of this equation. And these are also going to be my zeros of the graph, or simply put, they're just the solutions of the above equation. Okay, so we finished the problem. Those are my answers. I forgot to put in here, a little commentary of the different factoring that I'm using here. So I'll put that in this one. This first step, we used the greatest common factor that we pulled out, right? And then the next step, we used the the two parenthesis method, but more specifically, we use the difference of squares. All right, so the main thing that we're trying to do here is use our factoring. And then after we factor it completely, then get our answers from the equation that we started with. Now let's look at the graph. If we were to graph, and by the way, this graph that we're doing here is y equals 4x cubed minus 9x. That's what we're trying to sketch here, is just the left part of this right here, as if to say y equals that. And so the three answers that I have here are all the zeros of my equation. So I'm going to make a scale that's kind of big. Let's say that there's my scale. And my zeros are going to be, again, one of them is going to be at 0. The other one's going to be at positive 3/2, and one at negative 3/2. I know that since this leading term here is x cubed, I know that anything that's x cubed is going to produce a graph that has an x or an n behavior just like the last graph. It's going to go up and to the right, down and to the left. So I can pretty much figure out what this is going to be, because this is going to go up and to the right. I know that at this left hand 0, it's going to go down and to the left. And so there's really no other place for this graph to go, but it's going to go up, and then it's going to reach 0 again, and then it's going to come back up through here. So I'd say that's what my sketch looks like. But let's look at that on the graphing calculator and see how close we are and if any adjustments could be made. So I go to y equals, and I type in my function. So I have 4x cubed minus 9x. And we graph it. And you can see we're pretty much right there, right? We have 3 zeros, 0, 0, 0. And you can see the shape looks pretty similar to what I have right here. Again, if you look at these little relative maximums and minimums, we didn't do a perfect sketch. If we were going to do a perfect sketch, then we would have to use maybe a table of values and get a bunch more points on the graph. But we don't need to do that necessarily here. This is a decent sketch. It shows the zeros and it shows the general behavior of that graph. All right, one more. Let's look at C. Okay. Again, we are going to try to solve this equation. The only way that we really know how is to factor. And so we go to our factoring practices and we say, okay, how am I going to factor this left-hand side? Well, it's 4 terms, so I'm going to go ahead and use grouping. And so I'm going to rewrite this a little bit. When I use factor by grouping, I want to especially be careful, like right here, that can be a little confusing. That minus I'm going to make to a plus, and then put this as a negative 4x squared plus 20x. It's really just the same thing, but I like to group these so that I have an addition in between here, and I don't try to like cut this off in a weird way. So I'm going to make groups here, and by the way, there was no common factor that I could pull out, so I didn't have to do that. I'm going to look at each of these groups, and the first group, I definitely can pull out an x cubed. And so what's left over here is going to be an x minus 5. And then I look at my second grouping right here, and you can see there's an x that's in common and also a 4. Since I want this to come out as x minus 5, if it's going to, I know that I'm going to have to pull out not a 4, but I'm going to have to pull out a negative 4. Because if I pulled out a positive 4, this would not come out as x minus 5. It'd be like negative x plus 5. Oops, and by the way, we also need to bring out that x. We're going to take out a negative 4 and take out an x, because both of those terms have an x in it as well. So what's left over here now would be an x, and then 20x divided by negative 4x would be negative 5. So you can see that we do indeed have some sort of matchup here. And so now we can combine this to x cubed, the red part, x cubed minus 4x, or plus a negative 4x. And then we have the x minus 5. Now, by the way, this is all equal to 0 as we're going through this process. So we just factored it. Okay, well, there's more to do here. This x minus 5 is done, right? But this x cubed minus 4x, I can certainly go further with. So x cubed minus 4x, I can take out an x, right? I can take out this x right here. And by the way, I misspoke earlier when I said there was no greatest common factor. So this is a good example of there definitely was a common factor here. So if you were watching the video and saying like, of course there is, you can take out an x, then you were right. You could have taken an x out right from the beginning, and you would have got the same thing here. So here's a good example of not seeing that and still saving your problem. Is now that I got to this red part, now I can see, oh, from this red part I can pull out the x. So I'm still okay in the problem. Okay, so this is still equal to 0, but again, what can we do with the x squared minus 4? We can factor that. X squared minus 4 is the difference of two squares. So this is going to be x. This red part right here is now going to be x plus 2 and x minus 2. And then x minus 5 is left over. All right, and this is completely factored. We finally got this down to the bare minimum. Now we can solve it. We're going to set all 4 of these things equal to 0, and again, use the 0 product property. If I multiply 4 things together, this times this times this times this equals 0, that of course means one of those has to be 0. So I basically set those 4 things equal to 0. And then my answers, of course, will be, first I'll have x equals 0. This will give me a negative 2. This will give me a positive 2. And this will give me a positive 5. So I have 4 different answers here. 4 different answers. And there we go. We solved that equation. And by the way, the factoring methods that we used here, we used the greatest common factor, although we probably should have used it in the beginning. I used it over here because I forgot. And we also used grouping. We used factoring by grouping to get this first step here and to group these different. We also used right here, we used the difference of squares, difference of 2 squares. So I'll just put in here difference of squares. So there's a rundown of all the factoring types of strategies that we used to get our solutions down here. Now, again, the graph, let's go ahead and do that. We have 4 zeros here. I'm going to go ahead and label this. Let's see, 1, 2, 3, 4, 5. And I'll put some off to the left here. I have 4 zeros, so I have 1 in the middle, 1 at 2, 1 at negative 2, and 1 at 5. And again, think about what you remember from an x to the 4th. What is a something to the 4th? What does that graph look like? The end behavior, just like x squared, is going to look like the same thing. It's going to go up to the left and up to the right, if you remember that. So on my sketch, I know that this 0 off to the right, it's going to go up and to the right, and over here on the left side, it's going to go up and to the left. And now in between here, we're really just going to be going in and out, and I'm just going to sort of guess here. It's going to go up, and then it's going to come down, kind of perform like a W-ish type of graph here. And as you get into future classes, you'll probably break this down further and further and look at different types of problems where you can have different multiplicities here, they call them, where you don't actually cross the x-axis, you just touch it and go back down. But for now, that's what I think the graph looks like. but definitely check it on the calculator here just to practice those skills. So we have x to the fourth minus 5x cubed minus 4x squared plus 20x. Graph it, and you can see that there really is a w there. If we zoom out, or let's say we take that window and let's make this, you know, negative 5 to positive, oops, let's go back to that. Not a minus here, we want to use a negative sign, so negative 5, this is going to be to positive 5, and then let's scale this to negative 20, we'll say, and the y value to positive 20. See if we can zoom out a little bit, and we're pretty much there. Well, let's just go and make this, let's go to 8, and we'll go down to negative 30. Let's see if we can make it a little bit better. And it goes even further down there. So again, you can still see the W shape, right? And you can see the end behavior is correct, going up, left, up, right. And so there's my sketch of my graph. I'm not too worried about, you know, the inside here not being correct or perfect, but I certainly, if I were to make a better sketch, this really goes down further, right? It goes down further there. But do the best you can. Look at the calculator to make any adjustments that you have, and that's it. I just want to add one more thing, and that is definitely, you know, on your calculator, use it to check your answers, right? The main goal of this problem was to solve it. We had 0, -2, 2, and 5. And on our calculator, we can verify that we have the correct answers by looking at those zeros. And so remember how to find a 0. Now you can pretty much just look at the graph and just see, yeah, -2, 0, 2, and 5. That looks right on the money. So I think it's a good verification that you did the problem correctly. But remember too that you can go to second and trace and just hit number 2 to find each 0, and you could check these manually. So I could say that let's just find this 0 right here. So it looks like it's at 2, which it is, but the left bound of that, we just go anywhere to the left of this 0 or above it, and then you go to the right of that 0 somewhere, hit enter, then hit enter again, and it will tell you what the 0 is. X equals 2 is a 0. And so you could double check those 4 zeros that you have on your graph, and it's a really good way to check your answer too. And just make sure you do that and make that connection with the graph.